Hi ladies, this is lesson 7.4, and in this lesson we're going to evaluate logarithms, and we're looking at graphing logarithmic functions. So we have a few vocab terms. First of all, the logarithm of y with base b, and you'll see this written as log with base b of y. And in log b, or log base b with y of y, b and y are positive numbers and b does not equal 1. The second vocab term, common logarithm, this is a logarithm with base 10. So base is 10. And you'll see this written just as log of y. And then the natural logarithm is a logarithm with base e. Remember, e is that constant term that we talked about last lesson. And you'll see this written as ln of some number. So this key concept just outlines the definition of logarithm with base b as we just defined it. Log base b of y is written like this. All right, let's look at a few examples of what it actually means to have a logarithm. So in this logarithmic form, this is your base of the logarithm. So if you're converting this to exponent form, this is also your base of your exponential expression. So you're looking for 2 to some power, and that power is this 5 is equal to 32. So again, here is your base, 7 to the 0 power equals 1. And 13 to the first power equals 13. And 1/2 to the negative first power equals 2. So for this last one, remember your properties of exponents. 1/2 to the negative first power is 1 to the negative first over 2 to the negative first. Since you have negative exponents, you're going to switch from the numerator to the denominator. So you end up with 2 over 1, which is equal to 2. All right, try these next two on your own. Pause the video while you work. You're taking the logarithmic form and you're rewriting it in exponential form. So in the first problem, you should have 18 to the 0 power equals 1. In the second one, 2 to the 6 power equals 64. All right, here we have to do a little bit of backwards working. So we don't know what these logarithms are equal to, but we do know that they're equal to the exponent. So 3 to some power equals 81. So we just have to think about that for a second. 3 to what power is 81? And we know that 3 to the 4th power is 81. So again, this is just being familiar with exponents. and thinking a little bit about those. The second one, 4 to some power. Again, we don't know what it's equal to. So 4 to some power equals 0.25 or 1/4. And if we take 4 to the negative first power, we end up with 1/4. In the third one, again, we don't know what it's equal to, but 1/4 to some power equals 256. Now, since our base is a fraction and our y value is positive, is an integer, we know that x has to be a negative number. So we're really looking for 4 to what power is 256, and then we're going to take the opposite of that. So 4 to the 4th power is 256, therefore x has to be negative. Again, applying the rules of your exponents. And in the last one, again, we don't know what that's equal to, but log base 49 of 7 is 49 to some power equals 7. And we know that the square root of 49 is 7, so therefore x has to equal 1/2. Okay, try a few of these on your own, evaluating the logarithmic functions. You can pause the video while you work and unpause for the solution. Right, in these two that you did on your own, log base 1/3 of 9 is equal to something unknown, and that's what we're looking for. We're looking for that exponent. So 1/3 to the negative third power is equal to 9, and 16 to the 1/2 power is equal to 4. So if you remember from earlier this chapter, we looked at inverses. So in this lesson, we're looking at exponents and logarithms, and there is a relationship between the two. The logarithmic functions and exponential functions are inverses of each other. Okay, so g of f of x is equal to log base b of b to the x power. Since the base here and the base of our exponential portion of the function are the same, log of base b of b to the x power is just equal to x. And f of g of x, where you have b times, or b to the power of the log of base b to the x power, is also equal to x. So we're going to use these inverse properties to simplify these expressions. So here, 10 times log of 6.7, anytime you just see log without a base, that indicates that it's base 10. So 10 to the power of log base 10 is just this 6.7. In the second problem, we have log base 2 of 16 to the x power. 16 and 2 are not the same base, so we need to think of what is 2 to what power is 16. So we can rewrite this as log base 2 of 2 to the 4th power to the x power. right? So now since we have log base 2 of 2 to some power, we end up with just that exponent, 4x. In this next example, we're finding the inverse. So remember, when we find the inverse, we are going to switch the x and the y variables, and then we're going to solve for y. So the first step is to write the original function, which we have here, y equals log of base 3 halves of x. So we're going to rewrite that as x equals log base 3 halves of y. And then we're going to use our properties of logarithms to solve for y. So the first thing we're going to do is write an exponential form. So here's our base, 3 halves. Three halves to the x power is equal to y. And then we have just solved for y. So let's look at the second one. The second one, this ln, anytime you see ln, that means it's a logarithm with base e. So we're going to follow the same steps. We're going to write the original function first. Then we're going to switch the x and the y. So x equals the natural log of y minus 4. Then we're going to write an exponential form. So again, since we don't have a base labeled here, ln, the natural log, that means a logarithm with base e. So e to the x power is equal to y minus 4. And then we can add 4 to both sides to solve for y. So we end up with e to the x power plus 4 equals y. Okay, try these next two on your own. You're simplifying the logarithmic expressions. So like we did in example 3. So please pause the video while you work, and you can unpause for the solution. Right, in the first one, since you have 10 times log of 7x, since you don't have an indicated base, that means it's a common log, which is base 10. So 10 times log with base 10 of 7x, or 10 to the power of log base 10 7x is just 7x. And in the second one, again, you have to rewrite 27 as 3 to some power because that's what your base is. So 27 you rewrite as 3 to the third power. So log of base 3 of 3 to the third power to the x power, which gives you just whatever is in your exponent, which is 3x. All right, these next two, again, try these on your own. You can pause the video while you work. You're finding the inverse, which means you're switching your x and your y values and solving for y. So pause while you work, and you can unpause for the solution. So in this first example, you should rewrite by switching the x and the y. So you get x equals 7 to the 2y power. Now in order to get rid of that base of 7, you need to take log of base 7 of both sides. So log of base 7 of x equals log of base 7 of 7 to the 2y power. Now you can simplify using your inverse properties, and so you end up with log base 7 of x is equal to just that exponent of 2y. Now you're trying to solve for y, so you need to divide both sides by 2, and you end up with log base 7 of x divided by 2 is equal to y. Now in the second one, you don't have a base indicated, but it's ln, which means it's the natural log, which means it's a logarithm with base e. So remember now that x is your exponent. If you're going to rewrite in exponential form, natural log has a base of e, and y plus 6 is what that is equal to. And then lastly, you're going to subtract 6 from both sides in order to solve for y. So you have e to the x power minus 6 is equal to y. This is the end of part 1. In the second video of this lesson, we're going to look at graphing logarithmic functions. So please jot down any notes you have, and we can address them in class when I see you.